G'day, you're at maths. Just want to get us. I want to do a very quick demonstration to get us thinking a little bit about this idea that we're working on for the project over the next couple of weeks. The project talks about the idea of quadrilateral bisection. So what that means, quadrilateral means we've got a four-sided shape. Bisection means we can do some cutting in half, and in case it's going to be the side lengths. I want to demonstrate with a square. Now I'm going to use Excel because I think it's a good way to demonstrate what I'm doing. You watch as I'm doing it. At home, you'll be using graph paper. In class, you'll be using graph paper. Just a little reminder, if you watch the video that Mr. Huppets is on, where he talks through the task sheet, that was recorded last year and has last year's dates in it. So just be a little bit careful about that. The task is basically the same, just be careful about the dates. So let's set up here what we're going to do. I want to be working with a whole lot of like grid paper in squares. So what I can do when I'm working in Excel is I can highlight a whole lot of columns and rows, and I can change the width to what I want. So I want a width that is going to be give us some nice squares. So that'll go there. I'll get a whole lot of these as well, and I'll just adjust. If you adjust one, click on adjust one, the whole lot adjust, and that looks pretty good to me. I feel like we've got some pretty good working squares in the background. So remember the words we're working with. Quadrilateral, that just means a four-sided shape. And bisection, to cut in half. Okay, so bi means two sections, so we cut something into half. Now we're interested in the areas of different shapes. So let's start by drawing just the most simple quadrilateral that we can do, which is a square. So let's go 4, 5, 6, 7, 8 squares across, and 1, 2, 3, 4, 5, 6, 7, 8 squares down. That's a square that is 8 by 8, and that looks pretty good. That looks pretty much like a square as I look at that now. So this square, 8 by 8. Now, you might remember that the area of a square is side squared, so that's going to be 8 squared, 8 times 8, which is 64. Okay, and if not, you could actually count all the squares too to double check it. You go 1, 2, 3, 4, 5, 6, 7, 8. And then, so each row is 8, so it's going to be 8 plus 8 is 16, 24, 32, 40, 48, 56, 64 squares in total. Okay, so this square we'd say 64 units, because we don't really know whether, if I had been a little bit more careful, we might have said this was a centimetre each, but I'm not sure. We'll just say this is like each square here is 1 unit by 1 unit. Now here's where we come to the idea of bisecting. What we're going to do is we're going to find the point halfway down each side. So halfway down is going to be right here, and we're going to join it with the point halfway across the next side. So let's go to where we can insert a shape, and we'll just get a line, and we say, okay, this is halfway down one side, and I'm going to draw across to halfway down another. Okay, and you can see this is 1, 2, 3, 4 across, and 1, 2, 3, 4 to go. So we're pretty confident we've nailed that halfway. Next one is halfway down and halfway across. There we go, we've nailed that one. That's looking pretty neat too, just quietly. Next one, halfway across and halfway down. And my third bisection is done. And halfway across and halfway down. So there you go. We now have a shape drawn inside the square that 1, 2, 3, 4, so it's halfway across here. 1, 2, 3, 4, 1, 2, 3, 4, halfway across here. Just got a little bit dodgy here, but let's just ignore that. And so we can start to think about what's the relationship between the size of this shape in here and the big square outside. So let's see how we go counting up the number of squares we've got inside, the inside square. Just for fun, I might have a little bit of a have a little bit of a guess, just looking at it. I might say, to me, the inside square looks like it's pretty, or the inside shape, it's a four-sided shape, it's a quadrilateral. I'm going to say it's going to be 2/3. So inside shape, 2/3 area, the outside shape. Okay, so let's do a little bit of counting here. Okay, let's have a look at the middle. This middle pattern in here. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 squares in there. So that's going to be 12 units. Let's call this like little squares, 64 squares, because we're talking about areas. So we should be using a squared measure. So we've got 12 squares here. 64, so 64 squares in total in the L shape. We've just counted the 12. Let's go to either side now. We've got 1, 2, 3, 4 down either side. That's another 8 squares there. Okay. So we've got another 8 squares here. And then we've got another 1, 2. 3, 4. On the next lot, so 4 squares. Now we've got a bunch of half squares. So let's count them around. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got 16 half squares, which is going to be 8 whole squares. So let's add this up. The inside square, it's 12 plus 8 is 20, plus 4 is 24, plus 8 is 32. So the total is 32 squares. Now if I go back to what I thought, so we started with 64, and we said the inside square then calculates to, when we add it all up, calculates to 32 squares. My conjecture was the inside shape is 2/3 of the outside shape in area, and that's not going to be correct. I can see now that the inside square is half the outside square in this case. I don't know if it's going to be the same in every case. But that's a starting idea for how you can think about this task. You're going to be doing it with different shapes. You're going to be doing it on paper. And they're all going to be quadrilaterals, so different four-sided shapes like kites, rectangles, parallelograms. But that's just an example with a square of how we might start thinking about it. In fact, with that, I did a little conjecture there once I saw the picture. And it turns out I wasn't quite as right as I would hope I was. Okay, I'll leave you to be thinking about that, and we'll be doing some work on this in